Alright, so here's a problem that many of you are going to run into if you haven't already for the homework. Simplifying this radical that has an index 4, or maybe it could even have an index 5. So let's do an example. I hope this helps you out as you're doing it. Now, to simplify this expression here, I would start off by doing what rule 1, and again, I'm just calling it rule 1, something we talked about in class. I don't know what I called it in class. But what it said was is when we have an index and we have two variables living inside there, that we can break those apart. We keep the same index, but basically we're letting A live in its own and B live in its own radical. So I'm going to start this problem off that way, and I think it'll be helpful. That way we can just kind of do one thing at a time. So I have my index 4, and I'm going to put 96 in its own, and I'm going to put the S in its own. And again, you keep the index the same, and then I'm going to put T in its own. So I think this is maybe one of the simpler ways just to do a problem like this. So all we've done is use rule 1 that says, okay, I could break everything apart. Well, now what? Well, now we think about this. We have another rule that says when you have an index that matches an exponent, that those do what? Kind of think of it as they cancel each other out. And so that you can rescue this A from inside the radical. Or you simplify it to just A. Now, if you look at what we have here, well, we have an index 4, but we don't have any exponents 4s on the inside. That's the game we're going to play. We're going to take 96 and we're going to break it down into a bunch of factors and try to build those factors in such a way that there's an exponent of 4. Now, if you're not familiar with factor trees, you could Google factor tree. How do I do that? But it's probably something most of you already are familiar with. All we're doing is breaking down 96 into just a bunch of factors, such as right now what I'm doing, 2 times 24 is 2 times 12. Okay, well, 2 is prime, 12 is not, so we can just keep going until you have where you cannot break these factors down any further. We're right here at the end, 6 is 2 times 3. So this means that we found all the factors of 96. We have a bunch of 2's, 2 times 2, and I think we have 5 of them total. All right, I'll explain how this is helpful in just a second. The way that this is helpful is because now if you notice that we have a group of 2's, specifically here, we have 4 of them. And those 4 can be written as 2 to the exponent 4, which is sort of what we're playing with. We're playing with an index 4, so we want an exponent 4. Now this 2 and this 3 here, well, there's really nothing we can do with, those are not going to be helpful. So we're just going to multiply those back together. 2 times 3 is 6. Now this 2 to the 4 is what's really, really nice because we can rewrite 96 in this new way. Instead of writing 96, we're going to write it in its factors of 2 to the 4th times 6. All right, this is a 4 here. And then we'll be able to do rule 2 in just a little bit and save this 2. Now let's go to the next one. This s to the 8 is not so bad. We wish it was somehow written in terms of an exponent 4. And we can do that if we recall from our exponent rules. Well, 8 can be written as 2 times 4. And here's the way we're going to do it. 2 times 4. Why is that true? Remember, exponent rule says when you have an exponent here, raised to another exponent, these multiply. So this is the way we're going to write s to the 8. This is still s to the 8. It's just written in a new way. And again, we have this relationship between this 4 and this 4, where we can use rule 2 to cancel those out. But we'll do that in a little bit. That's the fun part, Now it's just all the hard work. All right, now t to the 13. Well, I want to talk about t to the 13 first because how could we build an exponent 4 or find some exponent 4 that's maybe living in here? Well, 4 times nothing gets us to 13. But let's think about what if we wrote it as T12? Well, hopefully that sends an alarm that, well, 12 is a multiple of 4. And let's do what we just did with the S. Let's write it as t to some number raised to some other number to get to 12. Well, that would be 3 times 4. And we want the 4 on the outside so that we can use the rule 2 in just a little bit. Then we're going to put our 3 in here. So we're going to be able to rescue this t cubed. Now, the t's still here, this other t. This is the 13th one. Okay, fortunately, we're not going to be able to rescue him. And his exponent is a 1. All right. So we found a new way that we can write t13. We can write it as t12 and t1. Again, those exponents add when we're multiplying. Now the t12, we found out that we can write it as t raised to the third, and then that raised to the fourth. And that's where the rule is going to come in. Again, this is all still multiplied times this extra little t. Okay. Now I'm going to do rule 1 just one last time. I'm going to take these two apart, t4 and 6, and let them live in their own radicals. T4 times index 4 with 6. I separated those using rule 1. I'm just using a whole bunch of rule 1, rule 2. Mostly rule 1 right now. Now this s, there's just one s, so we're just going to rewrite this again, the way that it is. S squared to the fourth, well that's just 2 times 4, which is 8. Now these t's we are going to separate. We're going to have a pair of these. Again, this is the t that's all by himself. Then over here is our special one. This is cube. They try to squeeze all this in here. Raised to the 4. Alright, now the fun part. We're going to use rule 2. Rule 2 says index matches the exponent. Goodbye. This index matches this exponent. Now we're not matching it with the 2 exponent, we're matching it with the 4 exponent. That's gone. And then also with t to the 3, with t cubed, we can eliminate this 4 with this 4. So what have we done? We've rescued some things. This this 2 just simplifies to a 2. And what else did we rescue? I'm going to write everything that we just rescued. S squared got rescued. It's no longer trapped inside of a radical. And this t cubed just got rescued. Again, you don't need the little multiplication dot. I'm just doing it just to remind us that those are being multiplied. And what was not rescued? Index 4, 6, and index 4, t. Now, since all of those, I'm just going to write down everything that was not rescued and just put it all back together. Okay, so rule 1 says you can break things apart. You could also go backwards. You can just put them all back together. All right, so 6 and t, they're both index 4. They're still trapped in there. I just put them under one house instead of 2 separate houses. All right, but this is what you would put for your final answer in Alex. Here's another problem. This one's already kind of show you the problem. Step 1, since you're doing index 5 on this new problem, you want to try to get everything built into exponents of 5 and rescue what you can, and then whatever you can't save, just write it back inside the little radical house with index 5. But see if you can do this problem, but show all the work so that you can get the practice. If you got questions, please talk to me in class or see me in my office. All right, thanks. Bye.